Hello, everyone, and welcome to the Inferyx webinar today for leveraging AI. So just a little bit about Inferyx before we get going. We are a global analytics company really helping to empower enterprises to build end-to-end scalable and robust AI applications with our low-code unified data management and analytics platform. Our speaker today is Yogesh Palrecha. With over 20 years of experience in data management and analytics, he has led teams across multiple industries within Fortune 500 companies and has a very strong passion for building technology products and solutions. I'm very excited for you all to be able to listen today. And please, at the end of our conversation today, feel free to ask any questions and we will be able to answer them. So sit back and enjoy, and I'll hand it over now to Yogesh.
Hi, Chris. Thank you. Can you hear me?
Yes.
Okay. This is going to be the agenda for today's webinar. A quick overview on that. We are going to look at some background on anti-money laundering. What are the quick stats within the industry? We will look at a traditional fraud detection architecture and what are the challenges related to that, how AML fraud detection solution is implemented within industry or within the banks. And then we'll also see what are the benefits of how we can alter that architecture to bring AI or artificial intelligence to improve the existing architecture, and what are the benefits due to the same. Then we will do a quick live demo, and once the demo is done, then we can take question and answers, and then we can have any follow-up things. So quick background on anti-money laundering. As you guys know, it's a billions of dollars a problem. In 2019 itself, if you see, banks have paid more than 6.2 billion in AML fines. And as you must be aware, the total amount of money that is being laundered globally is almost like 2 to 5% of global GDP, which is coming to approximately 800 billion to $2 trillion. And also they say the estimated global spending on AML fine was like almost at $10 billion in 2014. And banks have been spending a lot of money, which is estimated around 321 billion just in 2008. And it has been growing since then. So you can imagine we stand in 2020 and these estimates, some of these estimates are coming from 2008. In fact, it takes up almost like 1.2% of the Europe's total GDP. So you can imagine the size of the problem that we are dealing with here. Billions of dollars are spent just to control it and to save this, $1 trillion to $2 trillion problem, which is today's issue. So this is a traditional fraud detection architecture, which is used by most of the banks in North America or globally, I would say, which is typically using some kind of rule engine. So the way this process works is the business provides the requirement in terms of, along with what is instructed through the regulators in terms of what kind of scenarios we need to incorporate for monitoring the transactions. And depending upon those scenarios, then the scenarios are translated into rules, and then we apply some kind of thresholds and start monitoring the transactions. So the kind of data that is needed to support this kind of architecture is typically the data from the front office systems, which are the actual transactions. Let's say if you're monitoring like cash transactions, wire transaction, credit card transactions. So those are the transactions that flow in from the front office system into some kind of warehouse, which is basically a data repository within the enterprise. Along with that, we also pull the KYC, which is the customer information, the latest customer information on a periodic basis. Along with that, we also try to get the watch list information, which is provided by external agencies, the government agencies of various, like various regions and nations and countries, that's what they provide. Along with that, the banks are also pulling the external sources. These external sources could be some third-party organization which is providing information about the customers, the entities, or some macroeconomic factors, which is kind of then considered into the rule engine. So all of this data gets accumulated into some kind of warehouse, and some of the organization may not even have a warehouse. If it's a large organization, a multinational bank, a global bank, they certainly have a warehouse where the data is accumulated on a daily basis, and then this data is kind of processed and some risk scoring calculations are taken place, and then once all these transformations are done, then this data is pushed into the rule engine. This rule engine could be it could be a homegrown solution by the bank itself, or it could be even a third-party product. And then, the IT team or the business would go to these rule engine interfaces and then, start configuring the rules, make the changes. and then tune the rules so that they can start monitoring the transactions. Once the transactions, once it goes into production, then the rules are executed on a weekly or a monthly basis, depending upon which scenario you are focused upon. Alerts are generated, and these alerts they make into a case management system, where these alerts are then finally rolled up into cases, and then these cases are investigated by the analyst, the investigation analyst or the fraud analyst, who are kind of trying to find out what is suspicious about those particular accounts or customers in terms of what transactions they're doing. And then once the disposition of the case takes place, once it is confirmed that this particular case has got some kind of fraudulent activity going on, then it is finally reported to the regulatory bodies through a SAR filing. And also at the same time, there is management reporting that takes place to the business users in terms of, how many alerts are getting generated, how many are false positive, how many are true positives, how many cases are created, and so on. So all the statistics is kind of reported to the management. Now, to run this whole architecture, or to make this whole thing functional, there are many pieces here and many teams are involved. As you can see at the bottom of this diagram, we have a customer due diligence team, which is kind of focused on the KYC piece, but they make sure that the information that is being collected from a customer is on a periodic basis at a frequent interval, so that we are not kind of looking at stale information. And then the next step is typically a customer segmentation. So before you even start setting thresholds at a rule level, the customer segmentation team would basically take all the customers, and based upon the characteristic of the customers, they would perform a statistical analysis which will allow them to segment these customers into various groups. And then each of these groups are then defined some kind of thresholds. So there could be a high, medium, low type of categories within the segments, and then the high category group, you would probably try to monitor all transactions, let's say $10,000 or $20,000 and above, whereas the same threshold for a different category of customers would be completely different. So this is done based on a statistical analysis programs, and once those are executed, these settings of the thresholds are determined. So there is a separate team now, which is basically kind of configuring the rules and setting the threshold. This is done along with between the business and IT, where IT is kind of helping and in terms of getting the requirements from the business, and then finally going and configuring these rules into the rule engine. And as I said, it could be a homegrown product or it could be a third-party product. It just depends, how the bank is deciding which product to choose. So once that is done, then these rules are put into production, and then the thresholds are set and the alerts are generated. Now this goes on for a couple of months, and then periodically business would take a stab at it and look at all the alerts that were generated. And obviously, the biggest challenge that we are facing in the industry today, in the AML world, or especially for any fraud detection application, is the false positive. There are so many false positive, and that is kind of impacting the overall productivity of the analyst. That is one of the drivers, I would say, for which people are looking for alternate architectures, or architectures which can use or leverage artificial intelligence, which can definitely improve your false positive, or decrease your false positive and increase your true positives, and in fact create more productive alerts rather than creating thousands of those alerts, which are not really needed to be investigated in the first place. Okay, so moving on, then as I said, there will be a threshold optimization team which will periodically, so what they would really request is they would request a production copy of the data in some kind of QA environment or a UAT environment, where they would take this data and start analyzing the alerts that got generated using that data. And then their job is to really find out how we can optimize this threshold to make sure, or how we can change the settings of each of these rules, which will make sure that we have very few false positive and we have more productive alerts or more true positives. Also, at the same time, they want to make sure there are very few false negatives, because false negatives are the folks which have actually done some kind of money, or which has any kind of suspicious activity, but the rule engine was not able to detect. So using all the investigation feedback that is done by the investigation team, the threshold optimization team will actually tune these alerts, and then tune the rules, and then based on that, the productivity of the alerts or the quality of the alerts are going to be better. So this has to be done periodically. This has to be done for multiple lines of business that the bank is responsible to monitor their transactions. And it's a very tedious process because it involves a lot of data crunching. It involves a lot of analysis, where they have to use various kind of tools. So it could be a very time-consuming exercise. And this has to be done because this is the nature of the rules engine. This is one of the drawback of using a rule engine, where thresholds have to be periodically monitored. They have to be tuned. Finally, there is a alert or a case investigation team which is responsible to take these alerts, dig down into the alerts, and by looking at all the transaction information, account information, customer information, and then finally make a determination whether this alert is really should be reported or it's a false positive. And this is where the impact of the rule engine comes again, where all these false positives that are kind of pushed down into the investigation system, these analysts there would be like hundreds of analysts in the bank who would be investigating these alerts. And as I mentioned, 99% of these alerts are really false positive. This is not really because of the technology that we are using, or the data is bad, or the system is not doing its job. Is really the nature of the rule engine, which is kind of pretty static. And unfortunately, the fraudsters are so smart that they kind of outsmart the system, and then hence we need a new methodology to kind of do the complete AML, right? So just to summarize the challenges I was talking about, that once you start using a rule engine approach, a rule engine will have a fixed set of patterns that you're looking for. So that if there is a new pattern out there that the fraudster is kind of using, then you won't be able to detect that pattern because the pattern is not configured. So the rule engine approach has to be, anything that you want to monitor has to be kind of told to the system. Only then the system is going to really monitor on those. So this becomes challenging if the patterns are evolving. Then this is not going to keep up with those, and you will end up having a lot of false negatives, which means you will end up missing on those suspicious account which should have been marked suspicious and reported to the investigation team. As I mentioned, you have to do a periodic threshold tuning. This is a very time-consuming exercise, so it takes a lot of time and money for the bank to keep up on this. Again, the drawback of the rule engine, they are very static patterns. The thresholds are set, and hence the number of false positives are also very high. If you're using something which is very rudimentary system, or a third-party system which is not really exposing the nitty-gritty of the rule configurations, or which is not really helping you to drill down into these alerts in a very effective manner, then it becomes like a black box configuration. And what has really happened is the industry has evolved. I mean, all the ML products within the industry has evolved over a period of time. And by experience, we have seen that these systems are not really that transparent. There's a lot of customization that is required, and hence they kind of really become like a black box configuration, or a black box execution situation. Also within these models, they need a lot of flexibility with these products. If the product is not allowing you to create like on the fly models to do what if analysis and other things, then you wouldn't really be able to tune these thresholds very well. And there's a lot of manual involvement of writing programs or writing code to replicate these rules from a production or a third party product into a QA system, and then trying to optimize this threshold. So if they don't have really, if the product is not really supplying you a good modeling capability, or creating models on the fly, do testing, back testing, or what if analysis, then that could add up into the situation in terms of the time and cost, and that could again slow down the process as well. So overall, it impacts both in terms of the execution cost, also in terms of the efficiency of these statisticians, or the programmers who are involved, and also the efficiency of the whole program, right? I mean, you're generating, at the end of the day, if you're taking it too long, I mean, you're going to give up on it, and then finally you wouldn't be really optimizing that frequently, since it's the environment of the product itself is not that conducive, and that would result in inefficient AML program, and that would lead into unreported suspicious activity or accounts, and finally it will impact the image of the bank, or even boil down to being fined for the bank. So these products that are out there, which are all rule engine driven products, they were built with legacy technologies, and they just couldn't scale up with the today's world, where there's a lot of volume of data available through big data systems. So with these products, it is just merely impossible, and then we end up having silos, because since this product cannot scale up, we have seen situation with our experience that the bank would implement the same product multiple times in different regions, either because there's a data privacy concern across the borders, or it could be because of the the technology itself doesn't leverage to scale up, and hence your data remains very scattered, the systems are very separate, and there's a lot of duplication of effort going on. Okay, so scalability, performance, the nature of the architecture, which is a very batch driven architecture where you cannot really hook up anything in real time, you cannot make decisions on a real time. These are the challenges of the rule engine. If you are dealing with really a black box configuration driven thing, you may be also dealing with a very non-interactive platform, which makes it very time consuming for the business user or the analyst to go and start analyzing this data in a very programmatic fashion. So having the right tools and technologies or the right functionality within the product that you build or you plan to buy is a key thing to overcome all these deficiencies. So let's take a look at how AI can really help us. This is a sample AI-driven architecture, how bank would really implement AI within their ecosystem. Now, this is not specific to AML. This is specific. This can be used for any fraud detection architecture. Okay, so I'll just go step by step on each of these steps, and then we can take some. If there are any questions, we can take it during the Q&A session. So in this case, the source system, we are collecting the data collection process is on, and then this data kind of finally moves into this area where the whole analytics is taking place, where the AI piece comes into the play. So traditionally, as I said, the data gets collected, it gets massaged, and then it feeds into the rule engine. So instead of rule engine, now we are talking about an AI engine. And there are different configurations that you can use in an AI engine. I mean, you can do very basic classification techniques. You can train a model, and then, finally, after some testing and good accuracy, once you achieve, you can implement the model. But what we have done with the experience is we are not just leveraging the basic machine learning algorithms, but we are also using graph engine, which can really supplement your AI process. And it can enhance your capability of detecting fraud, I would say, by 2x or 3x. It really adds more visibility to your model, which in turn actually improves the the outcomes of the model, right? Because you want a model which can do a better job than rule engine. We are not just trying to replicate, or we are not trying to replace an existing system for the sake of technology efficiency, but we are really doing it so that we also get efficiency in the AML investigation as well, or AML program overall. So so this is basically where we engage in the form of services with our clients, and that's when we decide how we should really do this. So we already have a platform of our own which kind of helps us to build or configure these pieces, and then implement the model within your ecosystem. So what we do is, like, typically we take that data that is coming from the source system, we do some transformations, we calculate some features. Features are nothing but these are the variables that you want to kind of scan through at an account level or a customer level or at a transaction level, depending upon what you're trying to monitor. And then basically train a model using a couple of classification algorithms like random forest, gradient boost tree, decision tree classifier. There are many algorithms, but that really depends upon what kind of data you have, how many variables you have, what kind of history you have. That all will kind of decide which algorithm is the best algorithm in your situation. So that's more, again, a services engagement idea, but our platform, which I'm going to go through in the next slide, will allows us to choose those algorithms and give a try with different algorithms, and then kind of compare and contrast which algorithm is the best, and that is the one we want to choose in production. So the role of the graph engine or the graph analytics in this is, traditionally in a machine learning algorithm, you can take these features, feed into the algorithm, and build a model out of it, right? But with the graph engine, what we try to do is, like, we leverage graph in two different ways. One is for creating new features, which are typically not possible to be created using relational data. So we organize all the relational data in the form of a graph, and then we run few algorithms like community detection, nearest neighbors, when there are few graph specific algorithms which are very or Lubin algorithm, which are very very much applicable to fraud detection scenarios. And then we try to extract the features out of that. So let's say the data that you're receiving from the source, and with your business knowledge, you might end up building 40, 50 features. Graph analytics on the top of it will help us add few more features, which, as I mentioned, could not have been possible to achieve without graph engine. And then along with all that, we are able to train the model better, and then have better outcomes, and then finally implement the model in production within your operational system or investigation system. So there are two ways of integrating this model. You can run this model as a batch using our platform, or using any custom solution that you're trying to build, and then push those alerts into the investigation system. And then also we can hook up the graph engine within the investigation system, so that when the analyst is looking at an alert, they can do a 360-degree analysis, like a network analysis around that alert, like like this alert belongs to which customer, which account, who they have been transacting with, where exactly they live. So we can do a timeline analysis, we can do a link analysis, and many things that can be done with the help of graph engine. At the end of the day, it's not just about creating the alerts and pushing it to the downstream system. We also want to make sure that we kind of enable our analyst or the investigation analyst with a system where we are not just informing them about the alerts, but we are also helping them to drill down into those alerts in a very uh, in a very easy fashion. It cannot be that complicated where they have to dig into multiple systems or write some piece of code or write queries to look into the data. It just becomes very cumbersome, and at the end of the day, they just wouldn't be able to do a better investigation job. So if you want to improve their efficiency, because on one hand we are using an AI approach to detect the alerts or to produce the alerts which are more productive. So that way we know that we don't need thousands of analysts. We could probably cut down the team or maybe we can use them for other AML programs or AML issues. But then also we want to make sure that alert that is being generated is not only productive, but the investigation process itself is efficient. And that is where the graph engine can be kind of hooked up back into the investigation system, which can also improve the overall process of investigation system. So our goal is not really to just come and replace the alert process, but also, or the monitoring process, but also focus on the investigation side. So when you kind of improve both the aspects of the monitoring and investigation, that kind of becomes like an end-to-end improvement within your AML program. Okay. There is also a feedback loop from where you can take these alerts and push it back into, I mean, you can take the feedback of the investigation team and put it back into your training container, where we will kind of, or you can call it the AI engine, which can then improve the models, predictions going forward, and we can retrain the model and you get a better accuracy down the line. So moving on, this is how we kind of suggest a fraud detection platform. This is where Inferyx come into the game. We don't really go back to the source. If you're already collecting the data from the source, and if you're collecting all this data historically, storing in a warehouse, we can tap into that data, bring it into our platform, and then we can run some calculations, and we can train a model, and then finally generate the alerts along with the scores and push it to your investigation system. So we don't really suggest to replace your rule engine right away. This should happen over a period of time. So what should really happen is, on day one, we should install our platform. We should connect to your sources of data, pull the data, train a model, a machine learning model, and then finally we should run this model in parallel to your rule engine. And until we get a satisfactory result, or because this model is not going to do the best job on day one. The model development or the model accuracy is a very evolving process, because the model itself is learning by the mistakes it is making from day one. And we hope that over a period of time, which is between 6 months to 12 months, that's where you really get a very optimized model. And at that point, you should be in a position to make a decision whether we should continue with the existing rule engine, or we should just shut it down and then switch completely into the AI world. Because you may still have few products that you're trying to monitor a traditional way. They could be the new products that you're dealing with, and you may not have enough history of alerts, because if you don't have history of alerts, and if you don't have that feedback from the investigators on the historical alerts, then you won't be able to create or train an AI model. So AI really requires some kind of, because these are supervised model, you need historical data. So we would recommend that for the rules which have been in production for specific products, if they've been in production for a couple of years, that is the best scenario you have. Anything that you're trying to do newly, we can definitely take a stab of using AI, which is called unsupervised learning. But ideally, you may want to run a couple of months or years in the rule engine world, maybe like for the first year, and then accumulate enough feedback and use that data to train your model and improve upon from them. So you may be in a situation where you have few products which are still being monitored using the rule engine, and you may still want to use AI for some of the older products where you have enough history to train the model. Once these alerts are generated, then we feed these alerts back into the investigation system. As I mentioned, we have a feedback loop incorporated, which allows our model to be tuned on a periodic basis. And the rest of the downstream process still stays the same. That you are still reporting to the management of what's going on within your system, and any any particular account or customer which is marked suspicious is finally reported to the regulators, and SR is filed against that. Okay. So how are we really enhancing? I mean, there are different aspects to look at it. One is the ability of detecting new anomalies. So if you see like today with the rule engine approach, there are only certain set of scenarios that you're looking at, but there could be something totally new that you're not aware of it, a pattern that you're not aware of it. So we can use AI through our Inferyx platform, which can help you detect those new patterns. We are going to just mark, that what is there may be some behavioral change within the customer's behavior in terms of how they're transacting under their accounts. And once we flag them, then we can go and analyze and try to see what's really going wrong. It could be just normal, and it could be suspicious as well. But at least the model will help us detect those anomalies, and then those anomalies can be then investigated to figure out like what's really going wrong. Again, the auto tuning process takes place here. You don't have to just like a traditional rule engine. You don't have to do these every few months optimization programs where you're pulling the historical data, looking at the alerts, looking at all the mistakes that were done by the rule engine, trying to do a trial and error approach to find out what are the best alerts or the threshold that we should set. So this becomes very cumbersome. That cumbersome process can be totally eradicated, and then because you have a model which gets trained on a periodic basis in using AI, and this model is going to take care of the tuning part of it, like the threshold tuning part of it. It's going to automatically adjust itself to make sure that it is not making any. It's like reducing the false positive and increasing the true positive alerts. So again, as I was mentioning about the reducing the false positive idea, that is really the idea of AI, of using AI instead of rule engine. With the help of the scores that get generated for every alert through the AI engine, you can prioritize the case. So when we generate an alert through the AI engine, we also tell you, we give you a score between, let's say, 0 and 100, where 100 represent that, there's a high probability of this being really a suspicious account, and higher the score, higher the probability. So this really allows your investigation team to focus on which cases to look at first before the ones which has a lower probability. Our platform also gives you a complete configuration driven approach and traceability. The platform really allows you, it's not a black box engine. If you use our platform, then you would get an opportunity to configure all the scenarios if you want to do a rule engine approach, configure all the models if you're taking an AI approach. And we are really hybrid in nature. We are not saying that you replace all the rule engine and bring AI. We would really recommend that you use both methodologies to begin with, and hence we don't want you to operate like two different products or two different vendors and multiple technologies. So since our platform supports both the rule engine as well as the machine learning world or the AI world, you would be able to leverage and everything in a configuration driven way, which increases their efficiency. And also it's a very transparent system. I mean, once I go through the demo, you would realize it. Once you look at an alert, how easy it is to investigate and drill down all the way till a transaction level. And that increases your capability of investigation as well. We have few other features like the what if analysis. You don't need a separate tool for that. We have an inbuilt capability which will allow you to point any historical data and create supplementary models, or you can say challenger models, which can then, if they do a better job than the champion model, then they can replace the champion model, right? So the whole champion challenger idea is really an outcome of what if analysis. Once you are done with your what if analysis, once you are running the simulations, then you can really say that this model looks to be a better configuration than the previous one, and hence, we can kind of replace it. So all these activities, I mean, they can perform using one single platform. That's the goal of offering this platform, which is called Inferyx Analytics platform. So time for the demo. Let's get into a live demo, and then once the demo is done, then we can take up some questions. We would be happy to answer those. And if if we don't have sufficient time, then what we can do is we can always set up a follow-up session with you guys. Okay. So let's get into the demo now. So this is basically the interface to get into the platform. This is the Inferyx Analytics platform that we are looking at. I'm going to quickly log in here as my user ID. Once I log in, you should be able to, it's going to pop up like all the applications that are configured on this platform. Again, our platform is not just meant for, it's not just for fraud detection or AML. It does a variety of things for an enterprise. So when we work with a bank or an insurance company, we work in various, on various aspects. in terms of both in customer analytics, fraud detection, fraud analytics, HR analytics. There are various areas we are looking at. So today our focus of the webinar is more on anti-money laundering. So we are only going to focus on that. But if you're interested to explore other applications that are available, you can visit our website and check out what applications we have built in the past, or you can go through our webinar section and you will be able to look at the past webinars where you'll get an idea how this platform can help in other areas as well. Okay, so our approach to the enterprise is to have a single platform for the end-to-end data management and analytics. It's not just AML by itself. So the assumption here is the data is already prepared. We are pulling the data from the warehouse, and then we are trying to build an AML application. Now, this is a pre-configured AML application. This is like a starter kit, you can imagine. So we work with our clients where we take the starter application, and then once we understand the requirements, we start tuning this application in terms of adding new scenarios, building new models, maybe transforming the data, changing the, adding new features and so on. So initially you can come to the platform, you can do a basic data discovery. So let's say if you want to look at all the transaction information, I can quickly type in here transaction. It will show me all the data sets where we can find transaction information. So in this case, let's say I want to look at fact transaction data. So I can see quickly where the data is sitting right now, what are the different columns in that particular table. I can quickly glance through some sample data. And then I can plot an histogram. So this is purely, just doing a basic data analysis. Then we can look at the data profiling. So typically what happens in an AML world is once the data comes over, you want to make sure that you're periodically profiling the data so that you know that there are any changes in the values of the data or the ranges of the data, if it's a numeric column. Without knowing how your data is changing over a period of time, you're kind of shooting in dark. And because then you're making it a very robotic process, right? Where you know that you have a lot of assumptions. In other words, this is how the data should be, this is what we are going to look for, and this is what the result going to be. And that's not the approach we are taking. What we really do is we definitely bring in the data, we transform the data, we do configure your rules and models, the AI models, and we generate the prediction. That's kind of going on. But at the same time, we kind of go back into the system and we make sure we are profiling your data periodically so that we come to know about any changes in the data. And then once we know there are changes, we can generate the alerts, and then that becomes your input, apart from what you're running in the production process. So in this particular case, I'm going to pick a column that is available in the data, let's say amount USD. So it kind of shows me what is the minimum value in it, what is the maximum value of a transaction, what is an average value, median value, standard deviation, so on, right? So this kind of, and we take this snapshot every time you land in new data. So if you were pulling your data on a daily basis, we keep profiling your data, and then there is a data profiling module which kind of allows you to compare the results between two different executions. Maybe you want to see what was the profile of the data a month ago versus today, and then you can kind of compare and make a decision if you want to make any changes to your model or to your rule engine. Again, you don't need another product for it. As you can see here, there are various modules available. We have data visualization, ingestion, profiling, quality, preparation. So we have an end-to-end data management and analytics suite, which allows you to kind of do all of this using a single platform, including building dashboards. Then I can quickly look at the data quality itself. So there are data quality rules that are being configured once your data lands. And then based upon those rules, it's a combination of technical rules and the business rules that we get from the business. And then once you configure, it's going to kind of report you periodically how your data, what is the quality of your data. If the data quality falls below a certain percentage, you can set a abort condition where you kind of abort the whole process before it gets into the AI world. Because if your data is not good, then obviously your results are not going to be good. It's going to be like garbage in, garbage out. So to avoid that situation, we have an integrated data quality engine within the platform, which can be then used before you really start monitoring your transactions. Okay, if there are any bad records, is going to show up here. Now all the records are good because this is dummy data. And once it shows any bad data, you can kind of right click and drill down into the data to see what is wrong with the data. You can fix the data. Once the data is fixed, then obviously you can run through the predictions. If you wanted to do a quick lineage on the data where you want to see how data is getting into this particular table, because transaction data is the key data, and if you want to find out how data is really moving from my source system till this point, then I can click on data lineage, and it's going to kind of run through all the configuration that we have made in the platform, and it's kind of reverse engineer to find out, to show you what is the tracing of the data. So as you see here, the data is kind of coming in the form of files, getting loaded into tables. Then this data gets transformed through these red transformers. And then again, we are loading into tables, and we are taking the data back and trying to do further transformation and finally load the data. At any given point, if you would like to see this data, you can right click and say show details on this table or in this transformer, and you can quickly look at it. So again, the whole purpose is not a black box. It's not just about the AI. It's about the beginning of the journey of AML, which is really starting from collection of the data, quality checking the data, transforming the data, calculating the features, building the model. All of these steps, you can see right from a single platform. So this is a really powerful thing. If you can really imagine what all capabilities it can provide, and how it can, kind of bring you in a better shape and position as compared to how you operate your AML today. Now let's look at few rules. So this is the traditional what I'm going to show. Then I'm going to take you through the AI part as well. So this is a basic rule engine. We are going to take like one rule. We have around 60 rules configured here. I'm getting into the first rule. So this is an account focused rule where we are trying to monitor all the round amount outgoing transfers, wire transfers. So we kind of point to the data that we want to focus upon. We are pointing to the account summary. So the summaries are calculated on a daily basis. And then we are kind of very account focused in this situation. We can apply some look back parameters where you may say, I want to look at last 7 days of data, 30 days of data, and so on. You can also kind of exclude any whitelisted accounts. So this filter is the capability to do any kind of exclusions. We in the rule, we also allow you to parameterize the rule so that if you want to apply the same rule in a different region with different thresholds, different parameters, then you just define the rule once. And then this gives you the capability to kind of, you don't have to really redo the rules when you go to another region. You can just parameterize it. You can define your criteria. This is a very basic rule where we are trying to see how many transactions are taking place in the last 30 days and what is the value of those transactions. So you can kind of point and click and define all these criteria. You can also define the score bands. So for example, if you were scanning for, let's say, 10 transactions in this current month, and if you want to say that if it exceeds 10 transactions, let's say between 10 and 15, you may want to assign one score. If it exceeds 15 and 20, then you may want to assign another score, and so on. So you can define these score bands, and that is kind of, be very dynamic in terms of, it's kind of going to be very relative, right? In terms of how much volume of transactions are happening and what is the value of those transactions. Finally, we compute like a weighted average. So you may want to give like 60% weight on volume, 40% on value. In this case, I've done a 50-50 split because this is all on dummy data. And then finally, once we run the rule, it's going to create alerts. And then these alerts are going to be having a score, right? This is going to be generating like a weighted average score for each account, because right now we are running a rule at an account level. Then we go to alert generation. In the alert generation, you can configure rules where we can take these business rule outputs and combine them together and try to generate like an overall score at an account level. Okay. And then once the alert generation rule is configured, we can go to case management, where we can take all the alerts together. Like let's say if you were monitoring accounts, and if you have 5 different alerts on a given account, then you can combine these alerts into a single case and investigate that case. Now, this is totally up to the bank if they want to monitor an account level, transaction level, or a customer level. We don't really force for one or the another, but I think the tradition, or what really the best practice is to monitor the accounts when you are into an AML world, and then combine these alerts and generate a case at a customer level. So we'll get into the case management system. So this is the case management piece. I'll directly jump into the outcomes now. So these are the alerts that are, or the cases that are generated as a part of. Now this is the combination, by the way. This case we have generated based on some alerts, and these alerts are generated based upon the outcome of the AI model, right? It could be traditional rule engine plus AI. You can even combine it. So you may want to combine the power of rule engine plus AI together. Even that's a possibility initially. So that way you are kind of bumping up, let's say your rule engine was saying that the score on this particular case was, or on customer was like 60. So what we can do is we can take the outcomes of the AI engine, and if the AI says that I found it to be 60-70% suspicious, then you can bump up that score from 60 to 70, right? So you can bring more priority, and you can, that way you are focused on more quality alerts rather than all alerts. So in this particular scenario, I'm going to take a look at a particular customer. Let's say I'm going to pick the customer here. So this customer is having a score of 82. We'll dig down into this case. So we are showing you all the basic case information. Then we can look at the entity. Entity in this case, in this particular case, is a customer, because we are generating a case at a customer level. So all these fields are configurable. This is a very highly configurable system which allows you to the from top to bottom. It allows you to like configure each and every module, right? So whether you're in the rule engine world, alert generation world, case management world, data management, AI engine, everything is configurable. You don't have to write a single line of code to do all of this. So normally, if whatever you try to achieve in 12 months time frame, you should be able to achieve like in 4 to 5 months. I mean, it can really cut down your time by 2x or 3x even in some cases. So I'm looking at all the customer information. Then I can look at all the alerts on this particular customer. As I said, these alerts are generated as a part of the AI engine or the AI outputs that we have created. Then we can drill down into these alerts. As you can see, now this alert is generated at an account level. So maybe your AI engine is kind of pointing at an account level in terms of it alerts that it is generating. We're showing all the alert information here. We can look into the rule that has contributed. So there could be a rule which is, as I said, which could combine your traditional scenario with the AI outcome. And this could be one of the rule. So one of the rule here could be like a AI driven rule or AI driven outcome rule, where AI model is actually generating an outcome and you're using that, you're defining a rule on the top of it, right? So you're still leveraging AI. You're not fully and explicitly focused on AI, because you need to do a 360-degree perspective. You cannot just thrash out what has been running in production, or those rules that have been there out there for years and years. I think they are still valuable, but combining with the AI on the top of it, it really makes it more powerful and more clear. So we are looking at all the rules here. I can click one of those. These are the criteria that we were looking at. So we kind of tell you, and if you click on the view, we can take you to the transaction level. So we can show you the exact transaction that has met these criteria, these rules. And then, you will be able to do a better investigation in this particular case. You can add your notes. You can upload your attachments to this particular alert. Now I'm going back to the case. I can click on the link analysis. So this is the graph engine I was talking about. So what we do is we use graph in two perspectives. One is you can use the graph engine to generate new features based upon the information that you, or the observation that you make, and that improves your AI model. That is one aspect of it. Second is during the investigation process, we hook up into the graph engine to show you exactly how this particular customer or the case, it's like the case is on a customer. So we are trying to show you how this customer is connected, to various other nodes. So in this case, the customer Alan is holding this account. I've clicked on this account to see what other accounts it is connected to in terms of the transaction that it is making. It shows you where this person is living in Portland. I can right click and say, I want to see more details. I can click on the edge to see any kind of details which is more in between the relationship of two people. It could be an account and a person and a branch, and so on. And this is a bank we are looking at. This is basically a branch, and this is a location. I can right click and try to see the information, more information on this particular branch. Okay. So this kind of helps you to start investigating into your data. Right now, this is our development environment, so this is a bit slow. But depending upon the volume of data that we are looking at, we would suggest you how much horsepower you need to provide in terms of the machine capacity, and that would really drive your performance. So what I'm trying to do here is, while this outcome is coming, we can look at the other tabs. We can put some notes again. So this is at a case level. Earlier, we were looking at an account level or an alert level. You can upload attachments, any kind of investigation that while you're doing. And one other thing we have is we have an inbuilt workflow engine. This workflow engine, there is something called, if you look here, workflow manager, that allows you to customize your own workflow. Now, this is a very basic workflow for demo purpose I'm showing you, where we are assigning a case when a case is created, and then it gets assigned to level 1 or level 2, which can then further gets escalated, and finally it will be closed. So depending upon what options are available, it is going to dynamically generate the actions for you. In this case, the case is not even initiated. So we will initiate this case, and let's see what happens. Once you initiate the case, and once we go back to the workflow, it shows you now this is where the case stands. Now the options are, you can either assign to level 1, level 2, or FIU. So I should have 3 options here, as you see. I go to level 2 directly, and I submit. And then I can see that now the case is assigned to level 2. So this is how you can kind of, again, you don't have to write any code. Depending upon your business requirement, business and IT can work together to configure the system and, get things going. I mean, it's like point and click, no coding required. Going back to the link analysis, so as you see, that particular account has been transacting with many other accounts. We can click and see what is the transaction that is going on between the two accounts, and we can also further click on this particular account and see who it belongs to. Okay, so this kind of allows you to do like a 360-degree link analysis, and again, it's a very highly configurable thing. Um, so what I'm going to do is the same graph you can now even explore through the knowledge graph. So let's say instead of drilling down from a case or analyzing from a case, I would look at in a different manner. So I may want to start from a particular customer. So let's say I choose a customer. This is a customer I'm looking for, and then I submit. So what I'm trying to do is I can say that I want to start investigating my graph or exploring my graph rather than from a case. This is more of an exploration idea. I can start from an account, I can start from an address, I can start from a branch, I can start from a customer. There are many different ways you can do it. In this particular case, I'm trying to explore from a customer. As you see, he has an account, and this particular account is marked in red. It has a highlighting of red. This represents that this account has already been suspicious. So now you can drill down and see if this account has been transacting with other suspicious account or maybe other regular accounts, and then maybe those accounts are involved depending upon who's behind the account, right? Who's holding the account. So this can help you to kind of trace the whole money flow, the transaction flow between accounts and entities and organizations. And this is a very powerful idea. I mean, in the sense, this knowledge graph was just built through a configuration. There was no coding done. So depending upon your data and depending upon the discovery process during our engagement, we can decide that we are going to model a graph for you, which will contain customer addresses, phone numbers, and so on. And then each of these nodes there are numerous customizations you can do. You can decide what should be the background color of it. You can decide what icon you want to use. You can decide what should be the size of the node. You can decide how I want to highlight. You might say, I want to highlight all the accounts which are kind of, in a certain country or with a certain bank. Okay. You can decide any criteria you want. So that's how much configurable system this is. So if you are interested to further understand this product and our services, then you can reach out, to our sales team, or you can drop a email to us, and we will be happy to showcase you the configurability aspect of it. In today's webinar, I'm going to focus more on from an outcome perspective and more input and outputs rather than getting into each and every configuration. Okay. So it is still trying to find out. Seems like there are many transactions that are happening here. You can also apply some filters. So I can say here, only show me the edges. Edges are nothing but the transactions or the relationship between two nodes. So I can say, show me only the edges or the nodes or the accounts where there is a transaction of more than $10,000, right? So you can kind of filter it, and that way you will not be seeing like an exploded version of the graph. Okay. So this is going to show you something similar that we have seen in the previous screen. So I'll kind of move on in the interest of time. So now let's get into the data science piece. Out of the box, we kind of provide like around 39 or 40 algorithms. We keep adding new algorithms as we keep working on new use cases. So if you ask me just about the AML, you don't really need 40 algorithms. I think just with a bunch of algorithms, like 5 to 6 algorithms, you should be good enough from the classification perspective. So if you look for classification, we have many algorithms. I mean, there's like artificial neural network, which is like the deep learning. We have logistic regression, gradient boost tree. If there is a new algorithm out in the market, and let's say most of the time it is available in the Python library, we will be able to, or your admin can go and configure that new algorithm in like few minutes. You don't have to wait for days and days for us to release a patch. As I said, we have made the system very configurable, highly configurable, that really allows you to, write into your analysis. You don't have to really wait for new patches and things like that. So the algorithms are available out of the box. What you really need to do is you need to go and start building a model. So I'll show you how to build a model here. This is a gradient boost tree model. I'm going to pick one model here, which is pre-built. You're defining the model. It is written in Python. I'm selecting Python here. It's going to show you all the algorithms that are available in Python, and you can choose one of those. You can decide what you want to, what you want to name the prediction you want to make. So in this case, we are trying to find out suspicious activity. Then these are all the features of the model that we are defining. There are almost like 50 more features that are available in this particular model. Again, this is really an artwork. I mean, when we work with our clients, we understand their data, and then based on their situation, we kind of do feature engineering, right? So it's a process within data science world. You have to do the due diligence and then come up with a list of features. And these features can be then configured on this particular screen. You can define what type of the feature it is an integer value, double value, string value. You can do an encoding right from here. You can impute. Imputation is nothing but if you have like blank values within that particular column, then we can replace those values. So we can also kind of do data preparation as a part of model building. Okay. And then you can finally train this model. So we'll see how we train it. So we create a training request for this particular model. So here you can choose the model that we just created. You can point to the data that we have prepared in the data preparation area. Then you can point to the column which contains the suspicious indicator. You can map all the features. This is basically giving all the inputs so the model can get trained. There are a few other things you can do. You can hyperparameter, tune the model using hyperparameter concept. You can save the features in the output. You can calculate feature weights, and I'll explain you what is a feature weight. Then you can save the results in a file while you're in exploratory phase. If you want to save in a table, you can do that. You can decide how you want to split your data for training and testing. And if you have imbalance in your data, which is typically the case with the fraud detection scenario, let's say if you have a million record and only 5% of the data is really fraudulent, that's really a very imbalanced data set. So you cannot build a great model with that. So in that scenario, you have to upsample your data or downsample the other data. So if you are focused on upsampling, then you can upsample your fraudulent data, which is 5% to like, let's say up to 50%. So you kind of create a balance of the data, and that way the model can learn better, right? Once the model is trained, then we can go and look at all the results. So this is really during the exploratory phase while you're building the model, right? Once the model is built, I can click on this, try to look at all the outcomes. So this particular model is coming from Python. This is the algorithm name. This is basically running on sample data right now, how much time it took, what parameters were supplied while configuring the model. This particular screen, the feature importance is nothing but all the inputs that have went into the model is kind of telling you which inputs are the most relevant for the model to make a prediction, because we don't want to make a black box system. Our platform will tell you exactly which variables are the most important when you're doing a prediction. So in this particular case, all the outgoing wire transfers are the ones which is kind of driving. Now this is on the dummy data. In your scenario, it could be a completely different variable, but the point I'm trying to make is that this is not a black box engine. Then we can look at the performance metrics. What is the accuracy of the model? What is an F1 score? How many predictions are happening between fraudulent versus non-fraudulent, the confusion metrics, and so on, right? Then these tabs will show you the train and the test data, the data that was used for training the model and to building the model. So if there is some kind of audit, and if you have a mandate to save all this data, you can kind of save it. And then we can look at the feature weights. This is one unique thing. So what happens is the feature importance is like a generalized version at a model level, which tells you these are the top 5 features which are really relevant for your model. But the feature weight will tell you exactly which features are really driving that particular prediction. Now we are looking at one single prediction on a particular account, and it's saying that this is a suspicious account as per the model. And this is going to tell you each of the features which are kind of driving the model to predict a suspicious account, right? Everything on the right, which is in orange, is kind of predicting towards suspicious. Everything on the left, which is in blue, is predicting towards not suspicious, right? So these are all the reasons behind the prediction, I would say. So this can be very helpful during the investigation process. This information is available on the platform. We can ship this information to your downstream system. But if you would like to use our case investigation dashboard, if you want to investigate the cases using our platform, you are more than welcome, and we will be able to show you all this information. So my point is, you can either visualize all this on the platform itself, or we can ship this information so that we can enrich your downstream application, which would be a case investigation system, which is a custom system that is built in your in-house. Then we can use the model deploy. This kind of allows you, now there are many other features available. I'm not going through each and every feature. I'm just touching upon the features which are most relevant for AML. Here you can see that there are various models and what is different accuracy levels between them. You can pick a particular model and you can deploy the model. The whole idea of deploying the model is so that once you deploy the model, then it can be hooked up to now this is not too much applicable in AML world, because in AML more or less it's all batch. But if I was looking at real-time fraud detection, I would deploy the model in real time using this feature, and then connect my front office system or credit card transaction system to this particular model, which is deployed in real time using an API. Okay, so once you deploy, we create an API for you, and then that API can be used to generate predictions and do everything in real time. Then finally, looking at the data pipeline, this kind of shows me, this allows me to sequence everything as an end-to-end workflow. So in this particular case, let's say I'm looking at all the suspicious activity prediction models. I've created 4 different models. So this, using a drag and drop approach, you will be able to create this flow where you have these 4 different models using different algorithms, and then we are doing predictions on those. And then, depending upon whichever model does the best prediction, you will probably want to go with that and deploy it in production. But this is basically how you can kind of automate this process on a periodic basis. Okay. Finally, we will look at the data visualization. So there are many dashboards here. I'm just going to pick 1 or 2. So let's say I want to do a customer 360 degree. I want to choose a particular customer here. So just by doing drag and drop and through configurations, you will be able to build these dashboards in no time. So during our engagement with the business, with the clients, we kind of see what is the expectation and the requirement, and then accordingly we configure the dashboard. These are some out of the box dashboards where I'm trying to show you, like, you can show pictures, you can show personal information, address information, account details, and the alert that are generated on this particular customer. Okay. Now I can pick another dashboard if you want to see an overall summary of the AML monitoring. So again, the point is, you don't need another tool like a BI tool to just look at these outputs. Our platform kind of supports that as well. So as you can really see, this is really an end-to-end platform. I mean, to be very honest, in my experience with the AML that I worked with, you would need at least 4 or 5 different tools to put all this together, and I would say hundreds of programmers to build a system like this. So what we are doing it for you is we are bringing everything together, so that way you don't have to buy 4 or 5 different tools. You can save that money, you can save time in terms of integrating those tools, keeping up with their versions, keeping the compatibility up. You don't have to go through all of that. This platform is built using completely open source technology, and we can kind of leverage any technology you're using. If you're using a database like Oracle or MySQL or MS SQL, we can work upon that. If you're in the big data world, we can even hook up to your big data on billions of transactions or terabytes of data and still process seamlessly. So it's truly an open source platform. I mean, it's leveraging open source technologies. No, it's not an open source platform, but we kind of bring this platform together as a part of our services engagement. If you're interested to explore the platform, let us know. We can allow you to kind of explore it through our trial version, and then if there is an interest further, then we can get into a services engagement. So this is a AML monitoring dashboard. So here we are trying to show how many transactions are happening by country, by product types, how many alerts by each rule, by customer, and this is by by the USA map. And we also, I mean, this is a world map. I'm sorry, this is a world map. We are trying to show you how many alerts are there in this particular. So in this particular data, we have only United States and Canada data, and that's where it is showing you how many transactions are alerted versus non-alerted. I mean, how many accounts it is an account level. Okay. We also have a report section here where you can build reports. So you can run this report, and then finally, this can be PDF, Excel form reports, and you can kind of use it for any kind of management reporting. Okay. Again, so I think this brings us to the end of the live demo. Now we can switch back into the PowerPoint, and then we can take up some questions. Okay. So switching back here, I'm happy to take up some questions here. You can put down your questions. Since we have many people on the webinar, I would recommend that if you can shoot up your questions in the chat box, and then I'll read out the question, and then we can go from there. Okay. So I see a question here. Gentleman is asking, how can we combine the rule engine as well as the AI piece with using the single platform? How does it play together? Okay, so the way it happens is, as I mentioned, you may have certain lines of business which you still want to do rule engine, and there may be certain line of business which you want to start exploring the AI piece of it, right? You're not going to bring all the rule engine world into the AI world on day one. You may want to pick one line of business or one product which we find the most applicability for AI. Because for AI to run, you really need good volume of data. If you don't have those many transactions, AI is not going to do a good job. So that is what is going to determine how we kind of approach it. And then, the way we'll combine is like, as I said, the platform supports both the worlds. So we can configure your rule engine, rule-driven scenarios in rule engine world, and we can leverage AI for the AI piece, and they both can coexist. We can take the outcomes of the AI and put it back into the rule as a rule, and then generate an alert on the top of it. So we can really combine it. It's not a big deal. Moving on. So the question here is what volume of transactions this platform can handle, and what volume of transactions have you worked with our customers? So, well, we have worked with many customers here, but to be very specific, I mean, the platform is built using open source technology. Like, we use Apache Spark, which can, sweep through like millions and billions of transactions in no time. So as long as you have a platform, if you expect this platform to be implemented within your environment, and if you have some kind of distributed computing model or a platform like a big data platform within your enterprise, then there's no issue at all. We can process like billions of transactions, okay, on a weekly basis or a daily or a monthly basis, depending on how many transactions we are doing. Now, we have already tested our platform with the terabytes volume of data in terms of building the model using historical data. We have used last 3 years of history. We have aggregated that information and then trained this model with different parameters, different algorithms, and try to fine tune the model. So all of this can be done using the platform. There's practically no limit to it. The limit really comes into the play based upon the amount of resources you want to throw, and that's what is going to kind of drive the amount of time it will take. Okay, but in terms of the platform capability, it is ready to be consumed for any volume and any size of data. Okay, so we'll take one last question here. I think we are running at the top of the hour. So there's a question about supervised versus unsupervised learning. If we don't have labeled data, how do we approach it? Now, that's a very tricky thing. What we can do is, certainly supervised learning is the best situation to be in, and supervised learning is only possible if you have data that is pre-labeled, which means you should have alerts in place, or you should have accounts in place if you are monitoring accounts which are pre-flagged using your historical investigations, right? So if you're a bank who's been in operations for years, and I believe you must be doing an AML for at least a couple of years, like maybe 5, 6, 10, or 10 years, then you should have enough historical data. In that scenario, we can use your historical information, look at all the alerts, the productive, the non-productive alerts, train the model nicely. There's no issue with that. If you don't have labeled data, then we can look at the unsupervised algorithms, but the approach is going to be a bit different. So typically unsupervised algorithm is something like segmentation. So what we would have to do is like, we'll have to create multiple segments of your accounts or customers, and we'll have to monitor these customers if they move from one segment to another segment. If there is a movement happening, that means there is a change in the behavior, and that would give us an indication that there is something different about this customer now. Could be some suspicious activity happening, could be pretty normal too, it just depends. So we'll have to investigate using those ideas. And we can also use deep learning techniques, which will kind of, detect these anomalies for us. But at the end of the day, it cannot do the pinpointed approach what a supervised algorithm can do, where it can be more precise, but you still have an opportunity to track at an overall situation level, at an overall behavior, basically. Okay, so I'll move on to, I think we are getting to the end of the demo. This is our platform architecture. I'll just give a high level, few seconds overview here. So at the bottom, as you see, there are various sources of data that we can read through using our platform. We can read from flat file system. We can read from structured database, which means we can go directly into your source systems. So we never ask you that you give us data in a particular format. You can give in any format you like. And what we would do is, using our data management package, we will be able to process that data and prepare it for any kind of AML fraud detection. We can also operate on Hadoop on the cloud. We can do hybrid. We can read data from real-time queues if you're getting transactions in real time, and we can kind of act upon it. And in the middle, you see the Inferyx analytics platform, or you can call it an AI platform, which has all the bells and whistles. It has, on the left, you can see all the data management modules like data ingestion, profiling, quality, discovery, reconciliation, preparation, and then you have the business rule engine in the middle bottom, and then you have data pipelines where you can stitch all these steps together. We have a data science package which allows you to build visualizations, graph engine, machine learning, deep learning, AI, and then finally you can schedule all of this. We also have an inbuilt batch scheduler on this particular platform. This is the platform. These are the interfaces. I mean, that you just look upon it: the dashboard, the graph engine, the model output, the data pipeline. Okay. In terms of the technology and integration, as I said, we can hook up into majority of the databases, RDBMS. We can work with big data. We can work with NoSQL databases, or for all sorts of batch processing, we use Apache Spark. For something real time, we use Apache Kafka. From a machine learning perspective, we leverage all sorts of libraries. And mostly it's a combination of Python and Spark, and TensorFlow library for deep learning. We are cloud partners for all three major clouds, and we are happy to operate on cloud if you already have your data there, or if you want to do any kind of experiment or a POC, we can operate on AWS or Google or Azure. And in terms of the integration of our platform, we can do a REST API integration. We have most of these components available in the form of APIs, so you should be able to integrate seamlessly. Okay, so that brings us to the end of the webinar. Would be happy to work with you. If you have any interest to take this forward, then feel free to reach out to our sales team, or you can just shoot us an email at contact@inferyx.com, or reach out at this number, or just visit our website and fill the form, and we'll connect with you again. So I hope you guys got good information in terms of how we can use AI, and we are not just trying to put anything theoretical here. We have practically showed you how AI can help, and how we can build a model, how this can be implemented. So we have experience in terms of understanding the AML domain, and as well as working with the rule engine world, and now we can help you using our platform to leverage AI within your ecosystem. Okay, and we're not going to code from scratch. As I said, we have a platform in place. We can do a short 3 months POC with your data, and we can prove you the capabilities. And then if you're satisfied, and if we see a success story there, we can kind of roll out commercially within your environment. Okay, that's good. Then back to you, Chris.
All right, perfect. So thank you everybody for joining today. If there are any follow-up questions, feel free to please follow up with us, and we'll be happy to assist you in your understanding of Inferyx and how we can help you with your data. So again, my name is Chris Duncan. I'm the VP of Customer Success, and I thank you again for joining us today.